Hi everyone, and welcome to the MAT 211 review of basic probability. My name is Julia, and I work for the tutoring centers at ASU. So we have three fair coins, and we've tossed them, and the result is at least two heads. Whoops. Try that again. At least two heads. There we go. So we want to do two things here. We first want to write each event as an ordered triple. So what that means is we would have, parentheses, and inside we'd have 1, 2, and 3 for all three coins being tossed and whatever that result is. So this would be an example for 3 heads. And with that, we want to write a set that includes all elements of the sample space. So all of the possibilities for 3 coins. Regardless, we're not thinking about whether there's at least 2 heads here. We're just thinking about all the possible combinations of heads or tails if 3 fair coins are tossed. Then we also want to write the set for all the elements of the given event, where the given event is this at least 2 heads. So let's start by doing our part A of our problem. So we want to call this S, so that'll be S is our sample space. And we want to list out all the different possible combinations of heads and tails for our 3 fair coins. So we're assuming that these coins in this case are ordered. So we have like coin 1, coin 2, and coin 3, and each of those placements is different. So for instance, heads, tails, if we had that, that's not going to be the same thing as tails, heads, and heads running over here a little bit. But so we don't want to treat those as the same event. So let's start. The easiest way to do this is kind of start where they're all one thing and then just start adding, the other thing in at a time. So we're going to start with the case where we get all heads. Heads, heads, and heads. So there's only one way for that to happen, and that's when all 3 of them are heads. There's no way of reordering that differently. But now we can think about, well, what happens if we get 1 tails? Well, we can have our tails in our first spot, so tails, heads, and heads. We could have heads and tails and heads, so our tails is in our second spot. Or we could have it in our third spot, so that would give us heads, heads, and tails. Okay? Next, let's think about what happens when we have 2 tails. Well, in this case, we would have 1 head, so we can think about moving the heads throughout. So we could start with like heads, tails, and tails. Then if we move our heads into the second position, we would have tails, heads, and tails. Then lastly, if we had our heads in the third position, we would have tails, tails, and heads. And lastly, what about if we have all tails? Well, that's just tails, tails, and tails. And that's our full set. Note that there are 8 elements, or 8 different events, 8 different possible events in our full set. So S here is what we would call our sample space. That's why we call it S, just as shorthand, so we remember that. So now we want to think about, so part A is done. This is part A. And now we want to think about what, how to handle part B. So in part B, we want all the elements of the given event. So the given event is that we have at least 2 heads. So one way of writing this is that we would have our full sample space minus all of, so if we let's call E, so we're going to call E is the event of at least 2 heads. Okay. So this is possible events. We would say that the sample space minus all of the events that are not in E, so that's what this bar above E means, is that it's the events that are not in the set of events E here that we defined here. And when we do this, slash here, the slash means that S without the events in not E, okay? So in that case, if we remove everything that's not in E out of our sample space, well, that just gives us E. So that's one way to think about that. So let's think about what's not in E. So we could go through this all and just pick all the events that match E. That would be one way to approach this, but let's think about what's not in E, just to, try to think about this a different way. So if we have not E, that means that there's not at least 2 heads. So that means that there's 1 head or less. So what's in E not? Well, let's look through our sample set. So out of our first row here in our sample space, we see that in all 4 cases in our first row, we have at least 2 heads. So none of those are going to be in there. But in our second row, we see that all of our events in the second row have 1 head or less. So we know that not E is going to be H, T, 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 H, T, and then T, T, and H, and lastly, T, T, and T. So if that is not an E, if we remove all of this from our sample space, well, we're left with the first row. So if we want to rewrite our E, so we know that this whole second row is our not E. So let's just erase that because we already know that. So this whole second row is not E. So that means that the whole first row in this case is E. So this is going to be the sample of H, H, and H, T, H, and H, H, T, and H, and H, H, and T. So that's it. Let me make that E look a little more like an E there. So in conclusion, we have our full sample space. Let me erase my little arrows here. So we have our full sample space, S. That's for part A. That's A. And then we have the set of possible events, or the set of possibilities that satisfy the given event, which is that we have at least 2 heads. So this is B. So that's it. Before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can please visit our Tutoring Center website, tutoring.asu.edu, to find all of our resources. Additionally, if you are looking for tutoring services for your specific course, We have the tutor search tool, which you can find on our main website or by going directly to it at this full link here. And that will allow you to search for all of our tutoring services for your specific course. So thank you so much and have a great rest of your day.